In this presentation, we will discuss how to describe or summarize data using descriptive statistics. Descriptive statistics provide information on where the data are located, what are the most frequent values, and how much variables spread across people. In other words, they measure the location or the central tendency of the data and the spread of the data. In this presentation, we will learn about the mean, the median, the mode, how to identify and interpret quartiles, the interquartile range, and the 5-number summary. We will also learn how to identify outliers, how to compute and interpret the standard deviation, and how to analyze the center and spread of a distribution. One of the most common descriptive statistics is the mean or the average, which provides information about the location of a variable. And we all know how to compute an average. First, we calculate the sum of all values, and then we divide the total to the number of observations we have in the dataset. The mean is a measure of the center because it is an indicator of where most variables are located. In statistics, the notation that we use for the sample mean is the lowercase x with the bar above it, and we call it x bar. You don't need to use this notation if you don't feel comfortable with it, but I just wanted you to know what it means if you see it somewhere. It looks complicated, but it is just a simple average. Let's use the data in this table as an example. Student IDs were given based on the order in which observations were entered in the dataset. We have 10 students and we recorded their scores on a test for which possible scores range from 0 to 100. To obtain the average, we first add all the values that we recorded for this variable, which in this case add up to 861. Then we divide the total by the number of valid observations, or the number of individuals in the sample, and we obtain an average value. In this case, the average value is 86.1. If we look at the data set, we can see that most students have high scores on this test. They should get at least a B, with only one exception, which is student number 8, who has a score of 30. Even if we don't have a graph, we can see that this score does not follow the general pattern. It is an outlier. The question is, how much would the mean change if we don't take this outlier into account? If this outlier is not taken into account when we compute the average, we only have 9 students, a total of 131, and the overall mean is 92.33. The median is a summary statistic that indicates the middle point of a distribution. If we arrange all the values in ascending order from least to greatest, the median is the midpoint in between the minimum and the maximum value. We first have to order the observations in ascending order, and then we count half of the number of observations to find the median value. If the total number of observations is odd, then we have one value that is in the middle of the distribution. However, if the total number of observations is even, we have 2 values that are in the middle, so we have to compute the average of the 2 middle values. If you have difficulties finding the middle point, you can use the following strategy as a general rule. If you have an odd number of observations, like 9, you should add 1 to this number and get 10. Then you divide 10 by 2 and obtain 5, which means that the 5th observation is the median. In this case, you can just use this value. You do not need to compute an average. If the number of observations is even, the median is the average between the 2 middle values. Specifically, the median is the average of the observation number n divided by 2, where n represents the total number of values, and the observation number n divided by 2 plus 1. For instance, if we have 10 observations, n divided by 2 is 5. Therefore, we use the 5th and the 6th observations to compute an average. Statistical software computes the median for you, so you don't have to do this by hand every time, but it is important to understand how the median is obtained and what it represents to be able to understand and interpret it correctly. For instance, if we use the same example as before, we first need to reorder individuals based on their test scores. Notice that student with the ID 8 is now the first one on the list, and student with the ID 6 is the last one on the list because he has the maximum score. We have a total of 10 students, so the values that come in the 5th and the 6th place will be used to compute the median. In our case, the median will be the average of 91 and 92, so the median is 91.5. For the same data, if we remove the outlier, we have an odd number of observations. So we have only one middle value. Therefore, we don't have to calculate an average to determine the median. As you can see in the table, the middle value is 92. What is important to notice here is that the new median value, 92, is not much different than the value we obtained when the outlier was included, which was 91.5. Therefore, the outlier does not have a strong impact on the median, or as we say in statistics, the median is not as sensitive to outliers as the mean. This is important to remember, and this is why we should report both the mean and the median, especially when the data are skewed. Another measure of centrality is the mode. This is very easy to identify, and it is simply the value that occurs most often in the dataset. For instance, in our example, every value occurs only once except for 89, which is recorded twice. Two different students had the score, so our mode is 89. The mode is also used with nominal data to describe the most prevalent characteristic. The mode is a good descriptive statistic, but it is of little use for other types of statistical analysis. The mean and the median are both very important measures of centrality, but behave differently in the presence of outliers. Comparing the mean and the median can provide very useful information about the shape of a distribution. When the median and the mean are very close, the distribution of a variable is very likely symmetrical. However, when there's a large difference between the mean and the median, the distribution is likely skewed. These images illustrate where the mean, the median, and the mode are located in different types of distributions. The first curve illustrates a symmetric distribution. We can see in this image that the mean, the median, and the mode overlap. With real data, they do not have the exact same value, but they're relatively close. When we have outliers or the distribution is skewed, we record larger differences between these three statistics. The mode shows the value that occurs most often in a distribution, so it is always located at the highest point of the curve, and it is least impacted by the presence of outliers. As we mentioned before, outliers have a stronger effect on the mean than the median, so whenever we have extreme observations, the mean will be drawn to that direction. If extreme observations are on the right or towards the positive side of the x-axis, or these extreme values are very high, then the mean will be larger than the median. When extreme observations are very small or located on the left side, this is a negatively skewed distribution, the mean will be smaller than the median. The relationship between the median and the mean is used to make judgments about the shape of a distribution. Most of the times, we don't necessarily have a graphical representation of the data, and we need to decide based on the mean, the median, and the range of values whether or not the data are skewed, and if they are, in which direction they are skewed. The relationship between the mean and the median is an important piece of information, but in order to make an accurate decision about the distribution of the data, we must take into account some other information as well. Otherwise, our conclusions may be inaccurate. For instance, let's say that in a distribution, the mean has a value of 50 and the median is 55. So there's a difference of 5 points between them. If the values for that variable range between 0 and 100, like a test for instance, a difference of 5 points is not so great. We may have a symmetrical distribution. However, if the values range between 40 and 60, then the distribution is definitely not symmetrical. So these two numbers can only be interpreted in relation to some other information about the range of values as well as the spread of these values within that range. As I mentioned earlier, another statistic that we often use is the range of values. This is very easy to compute, and it is simply the difference between the largest and the smallest value in a data set. If we go back to our example, the maximum value is 100 for student number 6, and the minimum value is 30 for student number 8. To find the range, we simply subtract 30 from 100 and we obtain a range of 70 points. In addition to the range, we also have to determine where most observations are located within that range. As we saw earlier, some values are recorded more often than others, and most individuals tend to group around certain values that occur more frequently. But if we only know the mean, the median, the mode, and the range, we still don't have all the pieces of the puzzle. So to provide even more information, we typically try to identify the quartiles in what is called the interquartile range. This may sound complicated, but it's actually very simple. Just like we have identified the median, we're going to identify the first quartile, for which we usually use the notation Q1, and the third quartile, for which we use the notation Q3. Again, we have to order observations in ascending order from least to greatest. After we identify the median, which is actually the second quartile, we separate the distribution of values into two halves. The half that comes below the median and the half that comes above the median. Then we identify the median or the middle point of the first half of data, which is Q1 or the first quartile. And then the median of the second half of the data, which is Q3. The interquartile range is the difference between Q3 and Q1. We typically use the notation IQR for it, and it is very helpful because it shows us where the middle 50% of the individuals are located. Let's go back to our example and illustrate how to identify quartiles and how to calculate the interquartile range with this small data set. We already know how to find the median value, which is 91.5. If we apply the same procedure but use only the first 5 observations, the median of the first half is 89. This is the first quartile. Similarly, if we apply the same procedure to the second half, we find 94, which is the third quartile. We use the words quartiles because these values divide the distribution into quarters or groups that represent 25% of the sample. For instance, the first quarter includes the individuals who scored between the minimum value and Q1, and they represent 25% of the sample. The second quarter represents all the individuals who scored between the first quartile and the median, which is actually the second quartile, and so on. So obviously, each quarter includes 25% of the sample. Therefore, the interquartile range includes the individuals who score between the first and the third quartile, representing the middle half or the 50% of the sample. In our case, we can see not only that the median is 91.5, but half of the sample is located between 89 and 94, so within a 5 points range around the median. This range is located closer to the maximum than the minimum value, which means that the data are skewed at the lower side or are negatively skewed. In conclusion, the location or the distribution of the data can be summarized using what we call the 5-number summary. The 5-number summary includes the minimum value, the first quartile, the median, the third quartile, and the maximum value. Based on these numbers, we can compute the range of values and the interquartile range, which tells us where within that range the majority of individuals are located and whether or not the data are skewed to one direction or another. When the data includes some extreme values, we have to determine whether those values are in fact outliers. There's a rule of thumb that we can use to identify outliers. Cases that are further from the first and the third quartiles than 1.5 the interquartile range are considered outliers. To find the cutoff points, we multiply the interquartile range by 1.5 and then subtract the total from the first quartile and add the total to the third quartile. The values that we obtain represent the cutoff values to identify outliers. In our example, the interquartile range was 5, so if we multiply this value by 1.5, we obtain 7.5. We then subtract 7.5 from the first quartile to obtain the lower limit, and we add 7.5 to the third quartile to obtain the higher limit. Anything that is outside of this range is considered an outlier. The upper limit here is 101.5, which is larger than the highest possible score, so we don't have to worry about any outliers at the higher end. The lower limit is 81.5, and we do have a score that is lower than this. We have a score of 30, which we should consider an outlier. Another measure that helps us make judgments about the spread of the data is what we call the standard deviation. This measure is very frequently used, so it is very important to understand its meaning. The standard deviation represents the average distance of all the data points from the mean. The formula may look complicated, but the concept is actually fairly simple. First, we calculate an average or the mean of all values. Then, we take every observation in the data set and we calculate a difference between that value and the mean of the entire sample. So we obtain a set of differences. Some values are smaller than the mean, whereas others are larger than the mean. So some of the differences will be negative, whereas others will be positive. To get rid of the sign, we square these differences, and then we calculate an average of the squared differences. We do this by adding them all up and then dividing the sum by n minus 1, where n is the total number of observations in the data set, and n minus 1 is what we refer to as degrees of freedom. At this point, what we obtain is called the variance, which shows how much spread there is in the data. But remember that we squared our differences, so to obtain an average of the distance between data points, which is the standard deviation, we have to apply the inverse operation, which is the square root. People rarely calculate variance or the standard deviation by hand. This can be very cumbersome as the size of the data set increases. These measures are easily obtained with statistical software, but it is very important to understand their meaning. The standard deviation can be interpreted as an average distance from the mean. When we have a large standard deviation, the variables have a large spread, but when the standard deviation is small, variables tend to cluster around the mean. Like the mean, the standard deviation is sensitive to outliers. If only one difference is very large, the overall average distance from the mean increases significantly. This example shows how to compute the standard deviation for the data set in our example. We already know that the mean of all test scores is 86.1. Then for each individual, we compute the difference or the distance from the mean. You can see these differences in the third column. For the first student, the difference is 4.9. For the second one, the difference is 2.9, and so on. These differences are positive because these students have test scores that are larger than the mean. The only one with a negative difference is student 8, our outlier, with a score of 30. To get rid of the signs, we square the differences because we are interested only in how large these distances are from the mean, regardless of direction. The last column shows the squared differences. To obtain the variance, we compute the average of the squared differences. We do this by first adding them up and then dividing them not by n, but by n minus 1. We have to be careful about this. In our case, we divide the sum by 9, not by 10. To obtain the standard deviation, we just take the square root from the variance. Depending on the purpose of our study and the nature of the data, some measures of center and spread are more appropriate or more informative than others. For instance, we know that the mean and the standard deviation are sensitive to outliers. Therefore, especially when data are skewed, it is important to also report the median and the interquartile range and to explain their meaning. We usually report several descriptive statistics and explain the significance of each one. In this presentation, we discussed how to describe the distribution of a dataset using numerical measures such as the mean, the median, the mode, quartiles, and the interquartile range, variance, and the standard deviation. We have also explained the meaning of these concepts, how they compare to one another, and how they should be used. I hope that the explanations provided were clear and that the example that we carried through the presentation was helpful.